In this video, we're going to see how to enable loose coupling in our code by applying the dependency inversion principle. As we already saw, the dependency inversion principle states that high-level modules should not depend upon low-level modules, both should depend upon abstractions. So in our example, the business logic layer project, which is our high-level module, should not contain a project reference to the data access layer project, which is our low-level module. Now, if it did not contain such a reference, then it would be possible to effectively build our application starting from the business logic layer instead of starting from the data access layer. I have opened up a Visual Studio solution with a single C# class library project in it for my business logic layer. Inside the project, I have a folder called services which contains my book service class. The book service class contains a single method called addBook that takes in a title, author, and publication date. Inside the method, we want to create an instance of an entity class called book and persist it using some repository. So now I have added a new folder called entities which contains my book entity class, and the book class contains ID, title, author, and publication date properties. So back in the book service class, we can create an instance of the book entity class and assign its title, author, and publication date properties from the corresponding method arguments. Now we want to be able to persist this book entity using some repository. Now at the time of writing this business logic layer, we don't know if we are going to store this book entity in a database or an XML file or whatever. So in other words, at this time, we don't know what implementation of our data access layer is going to be. So when we don't know the implementation, we need to program against an abstraction. To put it differently, we know we want to persist our book entity using a method like addBookAsync that takes in a book instance. So that's the abstraction. But we don't know how that addBookAsync method is implemented internally. So we don't know whether the method will persist the book in a relational database or an XML file. So that's the implementation. So I have added a new folder called abstractions, and this folder contains an interface called iBook repository, which in turn contains the method we talked about, that is addBookAsync, that takes in a book instance. Now our book service class needs to work with this abstraction. So in the book service class, we can create a private field of type iBook repository. Make sure to bring in the namespace. And down here, call await repository.addBookAsync, passing in the book instance. Now this works fine at compile time, but it will fail at runtime because we cannot invoke a method on an interface without having an actual implementation. We will come back to this in the next section of this course where we talk about the various dependency injection design patterns that are available. Note that we have satisfied the part of the dependency inversion principle which states that our high-level module, which is the business logic layer, should depend upon an abstraction. Now it's time to implement our data access layer. I have added a new class library project to the solution for the data access layer. It contains a folder called repositories, which in turn contains the book repository class. This book repository class should contain the implementation of our data access logic. Now, according to the dependency inversion principle, our low-level module, which is the data access layer, should also depend upon an abstraction. That is, we want the book repository class to depend upon the iBook repository interface that's defined in the business logic layer. And we do this by letting the book repository class implement the iBook repository abstraction. And for that to happen, we need to add a project reference from the data access layer project to the business logic layer project. We can now implement the interface like so. Now our choice of data access implementation at this time is to persist our book entity in a relational database using Entity Framework Core. So we need to create a context class for that. So I have added a new folder called context, and inside that folder I have a class called simple book catalog dbContext. This class needs to inherit from dbContext, which is part of Entity Framework Core. So we need to go to Tools, NuGet Package Manager and Package Manager console and set the default project to the data access project and type install-package Microsoft.entityframework core.sql server as we will be using SQL Server Express local DB. Now we can inherit from DB context, make sure to bring in the namespace and override on configuring and say options builder dot use SQL server, and we can hardcode the connection string for now. Say server equals local db // mssql local db semicolon database equals simple book catalog db semicolon integrated security equals true, and then expose a public property of type dbset of book called books. And now in the book repository class inside the add book casing method, we can say using var context equals new simple book catalog db context and say context.books.add book and await context.savechanges async. Now we need to go ahead and create our database. For that we need to add a migration. So go to Tools, NuGet Package Manager and Package Manager console and make sure the default project is set to our data access project. Firstly, to use migrations, we need to install a set of tools. So say install-package Microsoft.entityframework core.tools and hit enter. Next, set the data access project as a startup project and add a migration by saying add-migration initial. We see we have our initial migration with its up and down methods. And finally say update-database. Now if we go to View SQL Server Object Explorer and then expand SQL Server, local DB and databases, right click the databases node and say refresh. We see our simple book catalog DB database, and if we in turn expand that and tables, we see our books table. Now that our data access layer is complete, let's go back to the book service class in the business logic layer and talk about a few things. So once again, nowhere inside the book service class we are creating an instance of book repository, so our compile time dependency to the book repository class is gone. Since the book service class is now not dependent on the book repository class anymore, we say that both classes are loosely coupled. And we enabled such loose coupling by applying the dependency inversion principle. But this completes just one half of the story. A book service object still needs a book repository object at runtime. So how do we provide an actual book repository instance for book service to work with? In other words, what about the runtime dependency between book service and book repository? That will be answered in the next section where we discuss the various dependency injection design patterns that are available. But before that, let's have a look at volatile and stable dependencies.